Hello, dear students. In this video session, we will be learning about free radical substitution reactions. First of all, let's discuss about the name. So it says free radical. What does free radical know, is, and how do we identify the free radicals? So whenever you see, basically we have to know that around an atom, in each orbital, we should have two electrons. You have learned it last year. So, and if you remember the octet rule, we should have 8 electrons outside of an element and of course we have some exceptions to the Lewis formula, but you have to know that at least on either side, on each side, we should have 2 electrons. But whenever we see, for example, whenever we see only one electron on one side, any side, this becomes free radical, free radicals. Okay, please do not forget that. Now, what about the substitution? We know that substitution is a replacement. The elements are replacing in each other. And also remember that alkanes can go to substitution reactions. Alkanes are hydrocarbons. Yeah, this example is provided in the slides. CH4 plus Cl2, CH3Cl plus HCl. Just don't forget this condition or any condition for the following reactions. And we need an UV light for this reaction to occur. Also, just remember these two words, homolytic fission. The name homo means same. Same. So homolytic fission, as you can see in homolytic fission, we are getting the radicals, you see. But a heterolytic fission, you see, hetero means more than one. And you see, we are getting one cation and one anion, just so you can identify. As you can see, in homolytic fission, one electron goes to one side, another electron goes to another side. But in homolytic heterolytic fission, both of these electrons goes to the one side, so it becomes negatively charged, and another becomes positively charged, cation and anion. So this is an whole example. We see this is methane plus chlorine. You see this, there is a substitution. Chlorine came to here and hydrogen came to here. But this process occurs in in 3 steps. Let's say 4 because the second step has 2 sub-steps. So first of all, initiation step. As we said, the first process that needs to occur is should be the presence of UV light, HV, and what we are getting from initiation step, we are getting the free radicals. You see, whenever you see only one dot on the any sides of the element, this becomes a radical. And from the reaction, what's happening? First of all, we are getting these radicals, and let me write the reaction in here: CH4 plus Cl2. So in the beginning, remember that we have these two molecules. They would like to combine. They would like to react. So under the UV light, what's happening? First of all, this UV light affects this chlorine and creating two radicals by homolytic fission process. And you see, we have these. This is gonna attack CH4 molecules. Remember, these free radicals, they are highly reactive. Also, they are highly dangerous. When whatever they can collide, they will disturb the structure of the adjacent molecule, the molecule that they are colliding with, and they are replacing any elements from that. So this is 7. You remember the octet rule, it needs to get one more electron. So it's taking one hydrogen, and creating this HCl molecule. And as you see, the hydrogen with one electron went away from CH4. So we are getting CH3 radical. Remember, in propagation step, this is the propagation step, we had one radical on the left side, and also we are going to have one radical on the right side. Please don't forget that. So one radical on the left side, one radical on the right side. And this radical is going to attack the chlorines. And once it attacks the chlorine, this is propagation step number 2. You see again, it's taking this one is taking one more chlorine with one additional electron, and we are getting CH3, Cl, and chlorine radical. You see in both propagation steps, we had one radical on the right, one radical on the left. Also for propagation step 2, one radical on the left, one radical on the right. You see this process is happening constantly. Imagine this is a reaction chamber. This one's is breaking, and this one's getting this. This one's attacking CH4s, and we are getting CH3 Cls, and again, these CH3 are attacking to Cl2. So this is a chain reaction. The chain occurring step by step. So at the end, we are remaining only the radicals, and these radicals, what they are doing at the end, and the radicals, they are combining with each other. As you can see, this is called termination step. In termination step, what's happening? The radicals are combining and they are getting a molecule. So at the end, all the radicals are gone. In termination step, as you can see, we do not have radicals on the product side. On initiation step, we don't have any radicals on the product side. So. And also we can have a side reactions. You see these radicals can react with the products too. So we can get side reactions, and from the side reactions, as you can see, we can get so many different product like CH3Cl, CH2Cl2, Cl3, CCl4, which is all in all these is called free radical substitution reactions. Let me quickly discuss about this one. This one is not a free radical because it doesn't have any lone electron. This one is considered a radical because we can see one. Also, this one is radical because we see one electron in here. Thank you for listening.